All right, we are on chapter 8-4, page 258. We're going to go ahead and look at question number 2. Question number 2, we want to solve this system of equations. We want to multiply first before we add or subtract. So for this one, we want to subtract these or add these, but there's nothing that's equal to each other. 2x and x, and then 5y and 4y. None of those are equal where we can just add or subtract them together. So what I'm going to have to do is I'm going to have to turn this into an equation that I can subtract or add from. So I'm going to see up here, I see that I have x and I have 2x right here. If I multiplied this by 2, it would give me 2x. But I've got to pass that out to the whole equation, just like I've got to pass out paper to the whole table. So if I pass this out, I get 2x, 2 times 4y gives me plus 8y equals 2 times 2 gives me 4. Bring down this equation, 2x plus 5y equals 7. I want to subtract this because I have both positive numbers. I want to subtract them from each other. So minus, and again, when I'm doing this, I've got to pass out that minus sign to the whole equation. So 2x minus 2x gives me 0. 8 minus 5 gives me my 3y here because I'm subtracting this. So 3y equals 4 minus 7 is going to give me my 3 right here, but it's going to be negative. Now that I've got this, I have 3y equals negative 3. I'm going to divide this by 3 for both sides. That gives me y by itself because these have canceled out now. So y is equal to negative 1. I'm already done for solving for y now, so I've got to plug that back in so I can get an answer for x. So I'm going to plug it back in to my original equation up here. So I have x plus 4y equals 2. Instead of writing y, I'm going to change it to negative 1. So x plus 4, negative 1, because that's the value of y, equals 2. When I see this here, I'm going to go ahead and multiply these together. So I'm going to break down my x plus 4 times negative 1 gives me negative 4 equals 2. So that's basically saying the same thing as minus 4. So what I can do to this is I can add the 4 to cancel that out. Add the 4. 4 plus 2 gives me 6 equals x, because this is canceled out now. So I have x equals 6, and I have y equals negative 1. When I put that in my coordinate pair, x goes first, so I have 6, comma, negative 1. I want to go back and check it if I would like to. So if I was doing a quiz or a test and I really wanted to make sure I had the right answer, I would go back and plug this in. So all I need to do that is to plug in the value of x and the value of y into the original equation. So it's x plus 4y equals 2. When I plug these values in, x is equal to 6, plus 4y is equal to negative 1 equals 2. I get 6 minus 4 equals 2. And when I calculate that out, I get 2 equals 2. That is correct. The next one I want to check also, 2x plus 5y equals 7. Plug in my values again, so 2 times, and our x was represented by 6. So 2 times 6 plus 5 times negative 1 was our value of y equals 7. 2 times 6 gives me 12 minus 5 equals 7. And I do know that 12 minus 5 equals 7, so 7 equals 7, and that answer is checked out too. So my final answer for this equation is 6 comma negative 1. I know that works out because I checked it with both equations. The second question we're going to look at was question number 7. So question number 7 is 2x plus 5y equals 16, and negative 4x plus 3y equals 20. I can't turn this 5 into a 3, but I can turn this 2 into a 4. So I'm going to go ahead and go with that one. So I'm going to multiply this by 2 in order to get my x's the same value. So 2, I'm going to distribute to the whole equation. 2 times 2x gives me 4x. 2 times 5 gives me 10y. And that's going to be equal to 2 times 16, which is 32. So now, since this is negative 4x, all I have to do is add it. I don't have to change the signs or anything because it's already going to cancel each other out. So negative 4x plus 4x gives me 0. 3 plus 10 gives me 13. Make sure I add on that y because it's 13y. And then 20 plus 32 is going to give me 52. So now I just divide by 13 to both sides, and my y is going to be equal to 4. I take that value, and I'm going to go ahead and plug it back into my original equation to solve for x. So I have 2x plus 5y equals 16. Plug in 4 for y, so 2x plus 5 times 4 equals 16. I just bring down my 2x plus 5 times 4 is 20. And I'm going to say that's equal to 16. Since I've just added on that 20, I'm going to subtract it. I don't need to divide because it's not multiplication, it's addition, so the opposite is subtraction. So minus 20 to both sides, I get 2x is equal to negative 4. When I divide by 2 to both sides, I'm left with x is equal to negative 2. So I've got an answer for x, I have an answer for y. My coordinate pair would be negative 2, comma 4, because it's x, comma y. And if I wanted to check that, again, I would just plug these back into my equations and check that. I like to do that, especially for quizzes and tests, because I know before I turn it in that I've got it right. So I'm going to go ahead and show that again. You don't need to show this step for all of your homework questions, but it's a good way to know that you have the right answer before you come to school tomorrow to get your homework checked. You would know right then, right now, that you've got the correct answer. So 2x plus 5y equals 16. I'm going to plug in for my x the value of negative 2 plus 5 times 4 equals 16. So 2 times negative 2 gives me negative 4. Let me slide that up, sorry. Negative 4 plus 20 equals 16. 20 minus 4 is 16, and I do know that 16 equals 16, so that one checks out. My second equation was negative 4x plus 3y is equal to 20. I'm going to go ahead and plug those numbers in again. So instead of x, I'm going to write the value of x, which is negative 2, plus 3 times the value of y, which is 4, equals 20. Negative times negative is a positive, and 4 times 2 is 8. So 8 plus 3 times 4 is 12, equals 20, and 8 plus 12 is 20, and 20 equals 20, so that problem checks out too. So number 7 answer was this right here, negative 2, comma 4.